Good morning, eighth grade. It's good to see you on this happy Thursday, which is a lab day. And if you would please take a moment to go grab your book, your science book, and open it up to page 191. We're going to be modifying things quite a bit here today, but page 191, the problem of the lab this week states, what is the relationship between the number of pinwheel blades and rotational speed? What in the world does that mean, you might be asking? Well, had we been together, we would have been using the template there in the observations to create several different types of windmill blades, affectionately called pinwheels, with different numbers of blades and observing which ones rotate the fastest and most efficiently given a constant velocity of wind generated by a fan. Well, we're not all together, obviously, right now, so I want you to draw upon some of your knowledge based on watching the videos this past week regarding wind energy and the generation of wind energy, specifically windmills. And if you can't remember, go back in your notes on the website and watch some of the videos, or at least look at some of the pictures of windmills, electrical generating windmills, to check out the number of blades that they have. That might be a good hint for you to consider when responding to the questions here in today's lab activity. So I'm going to start off with a quick little simulation, and then I'm going to ask you to do a little project on your own just to have a little bit of fun. So instead of generating electricity, we're going to use electricity today, and I just so happen to have a wind racer. Yes, this is a dragster here that is powered by wind. In other words, we have an electrical source, a couple of AAA batteries inside here that will be sending electricity to an electric motor, which, as you know from previous weeks, involve the relationship between electricity and magnetism in order to function. And that electric motor will then in turn turn the blade, which is like a propeller. And if you notice, this propeller, which is already pre-installed, you might say, on this particular kit, notice how many blades there are. Maybe another hint here. Well, what I'm going to do is a little demonstration. I'm going to send my little racer across the table here, and I just want you to watch the relative speed with which it moves using 3 blades. And then we're going to double that number and do the same thing, and I want you to make a similar observation. So here we go. Without further ado, our wind-powered dragster. And I do want to apologize to the STEM club participants. I'm so sorry we weren't able to meet this spring, but you can almost picture an aluminum can here, and this might have been one way to use a solar panel. We'll get into solar panels next week to propel the vehicle from one end of the course to the other. All right, so back on track. Here is our wind-powered racer. I'm going to start it at one end of the table here, and I'm going to turn it on. And then we're going to see how long it takes. We're not even going to use numbers. We're not going to measure it. We're just going to observe how relatively fast it goes across the table. So I'm turning it on. I'm waiting for full rev, and then I'm going to let go of it. Are you ready? Here it goes. Did you see that? Pretty cool. You want to see it again? I do, because it's fun to play with, so I'm going to show you again. All right, so I'm turning it on, holding it in place until it fully revs, and then I'm going to let go. Whee! Pretty cool, isn't it? Whoa, it's blowing papers all around here. Okay. So that's about how fast it goes with 3 blades. Now, I just so happen to have had another wind-powered racer too. Here it is, but you'll notice I took something off. I took the blade off because what I'm going to do now is double the number of blades by attaching the 2 blades together. And I'm going to alternate them so that they're spread out a little bit more here. And I'm going to try and get it on as straight as I can here. Let's see. This is very important to get it so that it's stable. But you will notice now instead of 3 blades, we got 6 blades. So I'm going to try this out and do the same thing. I'm going to let it rev up and then we're going to let it travel across the table. And I want you to compare how fast it goes relative to the first one. So here we go. Fully revved. See that? I'm going to do it again. Here we go. By the way, you can replay this video and watch it again, first time, second time. Maybe if you have a stopwatch or a clock with a second hand, you could actually make some measurements, see which one actually went faster. All right, so here we go. It's revving fully, letting it go. 6 blades. All right, now maybe it was easy for you to see, maybe it wasn't so easy, but my question to you is, in which case do you think this air racer traveled faster, with 3 blades or with 6 blades? In other words, which do you think is the most efficient design? Fewer blades or more blades? Now, we won't have the opportunity to practice with all of those blades, 3 to 8, with an activity. I mean, if you want to play around with it, great. But hopefully this video was enough to show you a little bit of a difference between the 2 efficiencies. And hopefully after checking out or replaying some of those videos with wind power, you'll be able to see the maximum efficiency with the number of blades on windmills. But now let's get to an activity, okay? So in your conclusion, by the way, you can just record what you observed. But let's have some fun creating your very own pinwheel from scratch. And all you need to accomplish this task is a piece of paper. Now, poster board works really well, but if you've got a piece of computer paper or just a piece of notebook paper, any kind of paper will do, and it will work just fine. So you need a piece of paper, a pair of scissors would be really good, and a little bit of tape. Not a lot, a little bit of tape. And one more thing. If you have any pins at home or needles, that would be great. A little thumbtack. I don't know if you can even see that. A little thumbtack is perfect for this activity, but if you have a straight pin, that works as well. If you don't have pins or thumbtacks, you could even use a paper clip and unravel a paper clip to get a straight line, but you'll need something to poke a hole through the pinwheel when we're finished making it, and then attach it to your last item that you will need, a pencil. Ideally, not a mechanical pencil. Well, it could be a mechanical pencil. Any pencil with an eraser on it, because you're going to be poking a pin into the end of an eraser. So if you don't have a pencil with an eraser on it, think of something else that you might be able to use that you could poke a pin into. All right, now let's get to how to build this thing. The first thing you need to do with your piece of paper is to make sure that you get it square. Right now it's a rectangle. Rectangles aren't going to work too well for this project. You need to create a perfect square. Now I know you don't have rulers necessarily at home, and that's okay, or protractors or anything of the sort. We can accomplish the task of creating a perfect square with a simple fold. So we're going to take this piece of paper, no matter what kind of paper it is, and you're going to take one corner You're going to take this corner, and this should be familiar to you a little bit from earlier in the year during the first marking period when we had our super simple STEM projects with single sheets of paper. So you're going to take one corner and you're going to fold it to the opposite side so that we can create a crease starting from the intersection of the two corners, matching up the sides, and making a perfect diagonal just like this. Now, by doing this, we've created a kind of a cool triangular shape with a little leftover portion. It's this leftover portion that we want to get rid of, but we want to get rid of it right along the line. So there's a couple ways you can do this. You can just grab a pair of scissors, and if you're really careful and talented, you can just cut right along where the papers meet, just like this. But if you would rather have a guideline, then what you can do is you take the paper like this, and you can fold it back right along that fold. And by doing that, you're going to create a line that you can cut along. All right, so that's what I'm doing. I just folded the paper back where the two papers meet, and now I'm going to cut along that fold to remove that little bit of excess. Just need to let my eyes adjust and my old hands from shaking. There we go. Okay. So I'm going to remove that little bit of excess paper. And now this paper is garbage. You can toss this into the trash can. Oh, 2 points. Yeah, and then what you're left with is a triangular shape. Uh-oh, I thought he said we needed a square, but we have a triangle. I think it's an isosceles triangle. Well, all we have to do is open it up, and we've got our perfect square. Okay, now you'll notice our perfect square has a nice diagonal fold in it. You can fold it back up again like this, and then take the two ends. Ooh, looks like a mask. Okay, stick them up. You can take these two ends and match them up, fold it together like this, real carefully, match up your edges real nice. Now we have a smaller triangle. And by the way, it's a right triangle. It's not wrong. It's right. It's a right triangle. And if we open up the whole paper again, you will notice, I think you can see the folds pretty well, X marks the spot. X marks the spot for what we are about to do next. Are you ready for the next step? I think you are. So here we do. Here we go. We are going to be cutting with our scissors. We are going to be cutting along the 4 fold lines. The 4 fold lines we're going to be cutting about halfway from the tip of the corner to the center. Not the whole way, only about halfway. So give me a moment, and I'm going to cut along these 4 folds about halfway, which means since there are 4 folds, we're going to be making 4 cuts. And incidentally, this pinwheel that we're making in our lab activity would have been the second one that we would make. The first one would have been out of a triangle with 3 blades. This is out of a square, and there will be 4 blades. Now, how are we going? Oh, wait, I missed one. I only cut 3. I have to cut one more here. Sorry about that. I'm not paying attention. There we go. Now we have 4 cuts. 4 cuts in the 4 folds. We got a cool little piece of paper that's cut in 4 different places. Now comes the tape and the careful part of bending paper. Not folding paper, but bending paper. So here's how we do it. We're going to take one of the sections of the triangles, and we're going to take that and carefully bend it to the center and tape it into position. I'm going to bend and tape, and then I'll hold it up for you to see a little bit better. And you want to go so the point of the paper is right to the center of the paper, just like that. And it kind of bends the paper like a little cone. See that? Now notice this triangle that we started with. If you're looking at it, we took the right-hand side of the triangle and folded that down. Now rotate your paper, and we're going to follow the pattern. We're going to take the right-hand side of the triangle and bend that down. And again, tape it right in the center of your paper. Just a tiny little piece of tape. Don't waste your tape. You only need a little bit. So a little square of tape. So see how we've done 2 blades now. Rotate, start in the upper right, bend that down, grab a little square piece of tape and do the same thing. And guess what? You can probably anticipate what's going to be next, because we're just going to rotate it one last time and do the same exact thing. So we're going to bend that paper to the center, put a little piece of square tape to hold that down, and when I hold this up, you will see that it kind of looks like a spiral galaxy. This is called a pinwheel. Now, it's not quite finished yet. We have to do a couple more things. We have now created 4 cool shaped blades to our pinwheel. And now comes the dangerous part, so be careful, please. You're going to take the thumbtack or the pin, and you're going to go directly into the center of the pinwheel. It helps, by the way, and you can use your science book for this. Do it over your science book. If you do it over your science book, you'll be poking a hole through the pinwheel and into some of the pages of your science book, and that's okay. Don't do this on expensive furniture where you're going to put a hole into wood or something like that. So we've put the thumbtack through the center of your pinwheel, and now you're going to take that thumbtack and you're going to push it into the end of a pencil eraser, and we're just about done. The last step is to turn your pencil around like this. Turn your pencil around to loosen up the connection. You want to minimize friction between the thumbtack and the paper, or the pin and the paper, or whatever it is you may have used. Now, once you've done that and it's pretty loose, now you're ready to start playing with your pinwheel. I'm going to demonstrate here at my desk, and all you have to do is hold your pinwheel slanted a little bit, and you're going to blow into the blades. Are you ready? How cool is that? Isn't that neat? Making a cool little toy out of a piece of paper, pen, and a pencil. Piece of paper, pen, and a pencil. PPP. We'll call it PPP. Now, what's even cooler is if you take this pencil with the pinwheel on it and run around the house. Oh my goodness, look at that. I didn't even have to run. Just moving it back and forth. Oh, how cool that is. How the wind catches the blade. Hold on a second. How the wind catches the blade, and the blade spins around, just like I'm spinning around in my chair, and I'm getting very dizzy right now, so I gotta stop. Whoa. Okay, you get the idea, folks, right? You get the idea. So, I got to catch my breath from spinning around. So here's a simple little way to make a cool little toy that will provide you with hours of enjoyment, a pinwheel. Now, an extra challenge, if you want some bonus points, maybe you could take some pictures and send them to me. Try to make a pinwheel with a different number of blades, like the lab activity, and see how it goes. Now, I'm not going to force you to do that for the lab because it's a little bit difficult. I would have been giving you templates in class to work with. So it's kind of tough, the geometry of it. But if you want to give it a go, give it a try and see which pinwheel is the best. You know what? When I stop this video, I'm going to be running around the house. Believe me, I am. I'm going to be running around the house with my pinwheel to check this out because it is so much fun. I hope you have as much fun as I have with making our pinwheel demonstrating wind energy this week. You have a great afternoon, and don't forget, take the practice quiz as many times as you can before you take the graded quiz tomorrow. And hopefully, I'll see you during the live chat in the morning, 11 a.m., so that you can earn some more bonus points as well. Take care.